Hello students, next let us look into the case where we are having a super mesh as well as dependent source. So which is the dependent source here? This one is a dependent source, this is a dependent source. As I always told, the first thing that we have to see when we look at a dependent source is whether it's a dependent voltage source or a dependent current source. Here we have the polarity, so this is going to be a dependent voltage source, whereas here we are having an arrow with direction, so this is going to be a current source, a dependent current source. So in effect, a current source, a voltage source and a current source, these are what we are having. Now for a mesh analysis, it does not matter if we are having voltage source, as we are having this independent 50 volt, this dependent source and this independent 52-volt source. The problem that is going to be here is this zero point 0.5 ix current source, because this current source is getting shared between two mesh, this and this one. And so we are having the case of a super mesh here. It's very important to understand the question before we start attempting it. See, here we are having 5 IY, isn't it? So 5 IY, what is IY? IY is the current that is flowing through here. Here I have forgotten to write the resistor. The resistor here is 6 ohms. So IY is the current that is flowing through this 6 ohms, and IX 0.5 IX is basically the current that is derived from IX, which is flowing in this branch. So everything is well in order. Now what we have to do is we have to mark the currents that we are going to use for our problem solving. So let me mark this as I1, let me mark this as I2, and let me mark this as I3. You can mark whichever way you want, it does not matter, the end result will all be the same. So we can conclude some of the things from here. One of the thing is Ix is going to be in the opposite direction of I1, therefore Ix is going to be equal to minus I1. So we will use that whenever we require it. Next, what is IY? IY is basically flowing in this direction. IY is basically flowing in this direction. So it should be I2 minus I3. Isn't it? It should be I2 minus I3. So that part I will write as IY is going to be I2 minus I3. So now we are set. Now I can directly write the equations. See, why I have written this importantly, why I have written this in the front itself is because I want to solve simultaneous equation. By looking at the question itself, I can understand that there are going to be 3 simultaneous equations for 3 unknowns. I1 is one unknown, I3 is another, I2 is the another one. So for 3 unknowns, I should get 3 simultaneous equations, and that is what is going to be my aim. So for that, what I am going to do is I am going to write the KVL. That's where we start, isn't it? So KVL at mesh 1. So I will write the polarity plus minus, here there is no polarity. So can I actually write for mesh 1? No, I cannot write for mesh 1. Why? Because there is a current source here. So since there is a current source here, I cannot complete this KVL equation. So what I instead do is I am going to consider this super mesh, this big super mesh, which combines these two together. If I go by that way, then it's going to be for this particular resistor plus minus for I2. Similarly, for 8 ohms, it is going to be plus minus. This is already plus minus, and the change that I have to write is that it's not for mesh 1, but it's going to be for super mesh. KVL at super mesh. So KVL at SuperMesh, I will write for the whole big circuit. So let me take back of the bogie. So this is going to be minus, this is going to be minus 50 volt. So minus 50, then again plus 10 I1 minus I3. Okay, then going this side, it's going to be back of the bogie again, so plus 6 times I2 minus I3. Good. Then I am having the 8 ohm resistor, so again back of the bogie. So let me first, yeah, so now I am having 8 ohm resistor, so this is plus 8 I2. Okay, and then the last one is going to be plus 52. So that is going to be equal to 0, from which I can write I1 term to be 10 I1. I2 also I am having this 6 and 8. So I will write both of them. So 6 plus 8 is 14. So plus 14 I2. For I3 I am having minus 10 because it is minus here. So minus 10 and minus 6. So if I have to write minus 10 and minus 6, so minus of, sorry, plus of minus 10 minus 6 I3. Okay, and then the minus 52, so I will write minus 50, sorry, minus 50 plus 52 is equal to 0, from where I can get therefore, or let me write it here, therefore I am having 10 I1 plus 14 I2 minus 16 I3 is equal to, so 52 minus 50 is 2, which I take the other side, it becomes minus 2. So this is going to be my first equation. Okay, now two meshes are over here. Which all two mesh? The first mesh and the second mesh I have already completed. Now I will go for the third mesh. Third mesh, I am directly having voltage source, so it does not matter. I will directly write the polarity. This is going to be plus minus. This is going to be plus minus. This one is already written, so I will go for the back of the bogie. So this is going to be KVL at mesh 3. KVL at mesh 3. So 10 I3 minus I1 plus 5 IY. See, now instead of writing IY, I will directly write this equation. So by that I will, save time a lot. So I will directly write uh, let me, yeah, so 5 times, instead of iy I will write I2 minus I3, and then the last portion is again back of the bogie is going to be plus 6 times I3 minus I2, that is going to be equal to 0, from which I can combine all the three. So therefore I will get minus 10 I1. For I2 I am having this 5 here and this minus 6 here. So 5 minus 6 is going to be minus 1. So minus I2. So minus 1 I2. I have not written 1 here because it's well understood. And then finally for I3 it's going to be 10 here, minus 5 here, and 6 here. So I will get 11. So plus 11 I3 is equal to 0 because there is no constant value. So let me clean it up. Yes. So now we have got the the second equation for the mesh 3. Now based on these, two equations, the first one of SuperMesh as well as the second one which is basically for the third mesh, I will not be able to find out I1, I2 and I3 because there are three unknowns. So I require three equations. So where the third equation come from? The third equation will come from the super mesh itself. I already told you once that always look for the branch where the extra current is. Here the direction is in this direction, so that will be I2 minus I1. So I can directly say, I don't directly write here, I will either write the junction here or I will write here. So I am free to choose from anywhere. So I will use the bottom one. So I will name this as node A. So here the current is I2 and here the current is I1 and here it is 0.5 Ix, where Ix is already given by this equation. So I will use that. Okay, so I will write KCL at node A. So KCL at node A, so I will get I2 is incoming to the junction, so I2 plus I2, I1 is going outside, so minus I1, then the current source is also going outside of the generation, so minus 0.5 Ix. Now instead of Ix I can directly write minus I1, so let me clear it. So instead of Ix I will write minus I1, so that minus and this minus will get plus, and here I will write I1 is equal to 0, or expanding it further, therefore I will get minus 0.5 I1 plus I2 is equal to 0. Now remember, I have already told you if there are three unknowns, then the third portion here will be 0 times I3. So if I am going to solve, if I am going to solve the simultaneous equations 1, 2 and the third one that I am having here, if I am going to solve these three equations, I can directly get the answer. Okay, so you can try that. Once we try it, we will get the answer as using the calculator, solving 1, 2, 3. So equation 1, 2, 3, if I am going to solve, I will get I1 value as minus 1.56 amperes, I2 value as minus 0.58 amperes, and I3 value as minus 1.11 amperes. And what is the question? The question is basically asking find the current through 8 ohm resistor. What is the current through 8 ohm resistor? Here we have already drawn the 8 ohm resistor, and the current that is flowing through it is I2. So without wasting any much time, I can write therefore current through R2, sorry, current through 8 ohm resistance is I2 itself, which is minus 0.58 amperes, and that is the solution. So what should we remember here? What we have to remember is that whenever we are having a equation, whenever we are having a circuit, we have to look at the circuit and first try to understand if this belongs to simple mesh or super mesh, or it belongs to the dependent source category, the dependent source category. Based on that, we have to decide what is going to be the our approach for solving this question. So thank you.